Great. Okay. Welcome everybody to the Introduction to Rocketry Airframe track. My name is Thomas. I am one of the co-leads for this track. The other lead is Brian Januzzi, and he'll probably be popping in later. And we have a couple mentors for this track. One of them is here with us tonight, Becky, and the two others are Ryan and Nolan. So we'll just hop right into it. So the objectives of Introduction to Rocketry are to basically give you a holistic understanding of what it means to build a rocket and how specifically the airframe fits into that. So throughout this track, you'll learn a little bit of rocket science, basics of rocket stability, how to run simulations in specific software. You'll also learn a little bit about SolidWorks, which is a major design software that a lot of engineering majors use, and just more people in STEM fields. It's becoming very popular. You'll also learn how to simulate a rocket in this software called OpenRocket. You can see on the bottom of the screen a picture of a rocket design. You can see the fins, the nose cone, all of the body tubes, and inside of the rocket as well, you can model payloads, parachutes, shock cord, and basically run simulations of a rocket before you even build anything, which is actually a really important part of the whole design process. So throughout this track, you'll learn all of those details. And you'll actually be able to build a rocket if you sign up for the Airframe track. We'll send you a rocket kit, and you can go through the whole build process. And we'll be available to assist you as well in breakout groups. So if you have basically any questions about the design and build process, we'll be there for you. And by the end of the fall, we plan to transition to designing a larger rocket. For plans in the spring, hopefully we'll be able to kind of build those larger rockets and integrate with the mechatronics and avionics tracks. So that's kind of like the overarching picture of this track. So you'll get a lot of design experience and also be able to build something and get your feet wet with that. So for us specifically, we'll be meeting Mondays, 8 to 10. And as it says, the format is a mixture of us giving you baseline knowledge about rocket science and theory and all of the jargon associated with rocket building. And then also when you start building those kit rockets, we'll be meeting with you in small breakout sessions, and kind of be there for you on that end. All you really need to get involved is a willingness to learn, and excitement to build rockets and make something fly fast, basically. SolidWorks and OpenRocket are the two major softwares we'll be using. OpenRocket is available online for free, and SolidWorks is accessible through the College of Engineering, and it's also available if you're outside of the College of Engineering. It's just a few more steps to get there, but we'll be able to get you SolidWorks. So don't worry if you're not in the College of Engineering itself. A lot of these slides are just kind of giving you a little more perspective in the form of pictures of what the track is like. We kind of talk about the same topics over and over, but just to give you a little more detail, the SolidWorks track that we offer as part of this course, it's going to be 3 meetings, and it's a very great introduction to SolidWorks. If you know nothing about kind of computer-aided design or SolidWorks, don't worry. We'll teach you all you need to know. And if you do have some SolidWorks experience, great. You'll learn even more about the software and be able to get some practice creating parts from scratch. And yeah, it's a great kind of segue into preparing for maybe a SolidWorks certification exam, or just getting better at computer-aided design. It's very useful. If you want to 3D print anything, you'll have to go through CAD first. So that's a great little aspect of this course that hasn't been offered in the past. And yeah, you can see on the bottom, on the left is an interesting payload that actually walks. So the idea would be upon recovery of the rocket, the rover would kind of climb out of the rocket and perform a certain task. And you can kind of see, you can get very creative with integrating payloads into rockets. And that's something that we kind of have to consider as well on the airframe side, because we'll be, cutting all of the tubes and integrating everything essentially. And on the bottom right, you can see an example of the electronics that avionics is working with. And we'll go into that a little more depth, but it's essentially as complicated as we'll see is a pressure sensor, a barometer that is integrated inside of an electronics bay. And it basically tracks the flight of the rocket over time. And also integrates with like ejection charges is something that you'll learn about, or black powder charges that ignite and basically allow sections of the rocket to break apart to release parachutes. So those are kind of the electronics aspects that we'll be covering. And then as for the coursework outline, kind of covered a lot of this already, but basically we'll be learning both design and manufacturing. And the exciting thing about Airframe is that it's a very hands-on course, usually, but because we're remote, we're learning more about SolidWorks and mechanical design. So you're getting a lot more background than you normally would through the introduction to rocketry track. So that's an exciting part of this year specifically. And this is kind of our timeline. So if you have any questions, feel free to speak up. I'd be happy to answer them. Yeah, that's essentially what we had prepared for tonight. So yeah, thanks for stopping in, and I will stop recording soon because I remember Shayla did not want us to record questions. So I will stop that now.